Hello and welcome to this video on chemistry by Perfect Scores. I'm Preetinder Kaur, and in this video the main topic is going to be matter. And these are still one of the introductory videos on chemistry. That means we cover all the basics and the fundamentals that will be used later on in the more advanced videos. So you must watch these all videos very carefully so that you don't get confused later on. So let's begin with what matter is. The definition is quite easy. It's anything that occupies space and that has mass. Now, mass is a confusing word. Mass actually refers to the quantity of matter that is there in the substance. And space is basically the physical dimensions, the space that it needs. Now, mass has some kind of weight assigned to it. And you need to know the relationship between mass and weight. Weight is equal to mass multiplied the gravity that is present there. Now, the weight can vary from place to place, but the mass is always constant. And why does weight vary from place to place? Because G can vary. I'm not saying from one place on the earth to the other place on the earth. I'm talking about, let's say, for example, the moon and the earth. The value of this constant G is going to vary from planet to planet. And because of that, the weight is also going to vary. On earth, unless you change the value of G, the value of weight is not going to change. So in this equation, out of these three variables, only m, which is mass, is constant for a particular body. Now, weight can vary, and it can be measured by looking at the resistance the substance has to its change of position or motion. And there is a property of mass to resist any kind of change in motion or change in position. That means if a substance is at rest, it will remain at rest. And if a substance is in motion, it will remain in motion unless and until an external force acts upon it. So this property of mass is known as inertia. So that is about mass, weight, and inertia. There are a few other important things that you need to know. For example, what do you mean by density? Now, density gives you an idea of the thickness. It gives you an idea of what is the relationship of the mass of a substance to the volume. That is density. So density D is equal to mass of the substance divided by the volume of the substance. Now, the basic unit of mass in case of chemistry, we're not talking about the SI unit, but the commonly used unit, which is gram. And volume is measured in either centimeter cube or it can be measured in milliliters. So these are the common units of density, either gram per centimeter cube or gram per milliliter. Now, for example, let's take two different materials. One is iron and one is cotton. If you look at the mass, let's take 1 kilogram of iron and 1 kilogram of cotton. Which one do you think will acquire more volume? Now, the mass is same, but the volumes are going to be different. Iron will require a smaller volume. Cotton will require a larger volume because it has to spread in a larger area than iron needs to, so that 1 kilogram can be fit. So if you look at the density, which is nothing but the ratio of mass and volume, the ratio is going to be higher in case of iron, and it's going to be lower in case of cotton. And that is how we know that iron is denser than cotton. Let's take another example. In case of density, We have two different forms of water. One is water as a liquid, one is ice. Let's take the same mass. Let's take 1 kilogram of water and 1 kilogram of ice. We're not removing or adding any weight. But there is one property that will be useful in this example, which is that ice expands. So whenever water is freezing and turning into ice, there is expansion that takes place. Means the volume is lesser in water and it is higher, it is more in case of ice. Because it expands, it needs to cover a larger area. So again, you have the relationship between mass and volume. Now, which one do you think will be more dense? Obviously, it's going to be water because the same kilogram is concentrated in a lesser area, so it has a higher density. And in case of ice, the same 1 kilogram is spread out in a, let's say, more expanded area. So the density is going to be lower. Since water is denser and ice is lighter in density, this is the reason why ice always floats on water. So that's another principle more commonly used in physics, that things that have a lower density will float, will be, let's say, on the upper level, and the things that have a higher density, those liquids or those solids, are going to be at the lower level. So that is about matter and density. Now, matter is not present only in one state. Now, this is a very easy topic, or subtopic rather. So you have states of matter, and they are three. These are the classical states of matter, because now with advancement in science and technology, we have lots of states of matter. But these three are solid, liquid, and gas. So if you talk about the volume and the shape, a piece of solid, if you cut a piece of solid, it will retain the same volume. Let's say you had 1 liter of something, or 1 cubic centimeter of a piece of wood or a piece of iron. It's going to remain the same no matter where you put it. And the shape, if you cut it in form of a cube, it is going to be in the form of a cube. It won't change itself. So those are the properties of solids. In case of liquid, the volume is same. 1 liter of water will be 1 liter of water no matter in which container you put it in. But the shape is going to change. So this varies. In case of gas, the volume, it actually depends on, it's actually different, and it depends on the container in which it is located. If, let's say, the container is closed, there will be a specific volume. If it's open, the gas will spread out. So we cannot measure the volume of an open container or of an open system. The shape. Now, gas will take the shape of the container in which it is put in. And that container needs to be closed. And that is all that we will be covering in this video. So we discussed what was matter, what is mass, weight, what is G, what is density, and what are the three common states of matter: solid, liquid, and gas. And remember, these are known as the classical states of matter. So at this level, at the SAT level, at the 11th and 12th grade level, you just need to know about these three classical states of matter. So thank you so much for watching this video.